I'm Olivier Corradi. I'm the founder and CEO of Electricity Maps. I want to take a huge step back actually right now and just tell you a little bit how I feel about climate change and what led me to create this company. And when I am a little bit sad or forgot what I'm here for, then I look at this. And so you have this plaque which is put in Iceland on a glacier that in 2019 lost its status as a glacier. And it reads, in the next 200 years, all of our glaciers are expected to follow the same path. This monument is to acknowledge that we know what is happening and what needs to be done, and only you know if we actually did it. And I think this is a testament for what we've been just saying before, which is that climate change is absolutely massive, and we need to make sure that the business case follows, else we're losing the mandate, and that resonated with me, and I wanted to emphasize it. So if we take a step back and think about climate change, energy is really at the cornerstone of that change, because if you think about it, most of the greenhouse gas emissions are actually coming from the combustion of fossil fuels for energy. And energy is the way that we're adding value into the world. Every time you need to move something from one location to the other, change shape, change temperature, anything, you need to put energy into it. And that's why energy is so important. And if you look at the opportunity or the challenge we're having now, is that on one hand, we're deploying all of these new renewables on the system. Wind, solar, storage is also coming online. On the other hand, AI is starting to use a lot of electricity. We're electrifying everything, electric heating, electric mobility. And the peculiar thing about electricity grids is that you cannot store electricity, or you have to use it immediately, or you have to store it into a different medium in storage systems. And that is why we'll come back to it. Location and timing is so important. So on one hand of the picture, you have the supply side of things, where you have a lot of intermittency, because as was pointed out previously, right now there's a lot of sun, but this morning there wasn't that much sun. The wind doesn't always blow. And then on the other hand, we want this facility to provide electricity 24/7. So how do we match both of these things together? So I want to tell you, I want to invite you on a bit of a nerdy journey with me, which is to think a little bit about where electricity comes from, because when I started this company, I realized that there's a surprising complexity in trying to answer the simple question of where does your electricity actually come from. And so you have a couple of paradigms here. The first one is called location-based. Location-based basically means depending on where you are, that will define the origin of your electricity and your footprint. Another way to look at it is if you have two neighboring houses plugged into the same grid, you're getting exactly the same electricity, so it just depends on where you are. The problem is I have no agency in order to be able to fund renewable projects. I don't get any credits if I do that. And so that's why this middle thing was introduced, which is called market-based. We call it the yearly market-based because in a nutshell, what we said is, let us make sure that if electricity is generated, we're generating a certificate, I can buy that certificate. If I buy that certificate, I get a claim as well where I can say, hey, my electricity is green, and therefore I'm getting cleaner electricity than my neighbor because I actually purchased something from a generator. Now the issue is, this worked well in the early days where we didn't have that much renewable, and that meant that on a yearly basis, I could be powered by 100% clean electricity if I just had purchased enough of these certificates. So I could have a facility powered by some solar certificates I was buying, and this facility could operate at night, for example. And of course, this is some of the things that are starting to make less and less sense as we're moving along. Positive thing, it is that it supported the renewable industry into starting to create more projects. But the negative thing is that it does sound counterintuitive that you can be powered by solar electricity during the night, for example. And then trying to reconcile these two things came along this 24/7 concept, basically saying I need to consume electricity and buy certificates in an area where the electricity that I'm purchasing will actually be physically deliverable to me. And it needs to happen at the same time as I'm consuming it in order to make sure that we're following the physics of the grid. And suddenly you have a solution where you are able to create change, fund change, but you also have something that's physically credible. And that is really showcasing a little bit the complexity that comes from the fact that you cannot, at a wind power plant, paint the electrons a certain color and just observe where they go. And that is why you have this type of complexity that comes up. And the reason I'm mentioning this is that the role of corporates in order to create change is tied to what incentives we're putting into place. And right now, for example, the Greenhouse Gas Protocol is undergoing a change where they are starting to revise what these definitions mean and what the guidelines are going to be with SBTi as well. So this is like pretty heavy stuff, but very, very important if you want to be if you want to stay on track with net zero. So talking about 24/7 specifically, and this was presented a little bit before, there's basically 3 pieces you need to get in order to create a successful 24/7 strategy. One, you need to understand what electricity you're consuming and when, and that's the consumption side or the metering side of things. If you want to establish a baseline, you need to understand where that electricity actually comes from. And then the third piece is, once you factor in your procurement, you start looking at the difference between your electricity and your neighbor's electricity. And we at Electricity Map do the third piece, which is the grid footprint, telling you exactly where does your electricity come from before you've done any type of purchase. And so I'll jump directly to this one. This is the Electricity Map product. This is the visual representation of it. It represents a map in real time showcasing you how clean the electricity you are consuming actually is. It's a free app. You can download it or you can go on the website. It shows on the left-hand side, you can see, for example, this is California, showcasing you all the solar production happening on that particular grid. We recently added global coverage, which means that we have built a complex piece of technology that adapts to the data available on the grid. Sometimes there's almost no data available from public authorities. And then we have our own AI models bridging the gap, generating the data. In some other grids, we have real-time information. The UK is a perfect place where there's like excellent data that comes, and we can tap into that. And that means that down the line, we can help corporates understand very finely what is the footprint that they're having. I want to just pause a little bit on one particular piece, again, nerding out a little bit these things, the importance of something called flow tracing. So we talked about how location is super important. Where I live right now in Denmark, most of the electricity typically comes from neighboring areas. We have typically 20 to 30% of the electricity that comes from Sweden. So if you want to understand, if you are a company charging your electric vehicle in Denmark, if you want to understand what is the climate impact of that, you're going to need to look at how electricity is generated locally, wind, solar, and so on, but also whether it's imported from the neighboring country and how that country is generating electricity. That country will also import from somewhere else, so you have to go back the whole chain of imports, almost going up, the supply chain to figure out where the electricity comes from. And we're doing that in real time over the European grid, which is interconnected, and we're doing that also in other grids of the world. And that is why in a country like Denmark, which doesn't have any nuclear, some of your electricity can actually come from nuclear because it's indirectly imported from another place, right? And this is quite important to realize, else you're making a mistake. What we're trying to build here is, we call it the Google Maps of electricity. I think that's a nice ring to it. We're trying to build something that is global, where we're covering the whole world, because we know that if you look at some of the very, very large electricity consumers in the world, they have a global footprint, and so we need to be able to address them. Another piece is, because intermittency is a large issue, we also need to be able to predict, because if you can predict how clean the electricity is going to be the next couple of hours, days, can have electric vehicles charging optimally, have data centers starting to use electricity at the optimal time. And the final piece is granularity. We talked again about location, extremely important to make sure that you're positioning your assets in the right location and utilizing the electricity at the right location to avoid congestion or avoid spending money building a bigger grid where, if you have placed your asset or consumed at a different location, it would have been slightly better. And maybe the last thing I want to leave you with is this platform that we're building is actually powering a lot of different use cases. It goes from the CFE optimization use case that we've understood a little bit before to, for example, with Google, where we're helping them change the time and the location at which the heavy computations are running in order to minimize footprint. And it's down to the consumer level, where we're, for example, working with Samsung, controlling your dishwashers and washing machines at home, telling you what is the optimal time to run these if you want to save money and be cleaner. And again, we're only going to succeed with this revolution or transition if we make sure that the business model follows sort of the impact model. And this is really what we're trying to do by having the cost of electricity also aligned with, let's say, the decarbonization opportunity, and hence why forecasting is so important. So I'll leave it there, but thank you so much.